So the question we've been left with is, if we have a logarithm in one base, how do we change that into a logarithm with a different base? So if I've got log base 2 of x, how can I turn that into a log base 10 of x? What needs to change between these two in order for me to make this change? And now that we know how to change the base of an exponential, this is actually going to be relatively easy. So we'll see how this works. We'll start by saying I've got the log base 2 of some number x. I don't know what that's equal to. I'm going to call it y. Y is just a placeholder dummy variable that we're putting in here to just hold the place of the answer that we're looking for. If we can find out what y might be in terms of a log base 10, then we've accomplished our goal. So y is just to hold the place of the answer we're looking for, but we don't really care what y itself is. However, I've got a logarithm here, so we can rewrite this as an exponential, and as an exponential, this is 2 to the y power equals x. But we know how to change the base of an exponential. This 2 can be written as 10 to the log base 10. I'll even put the 10 there just to emphasize that it's a log base 10 of 2. 10 to the log base 10 of 2 is the same as 2. And so we are going to raise that to the y power, because 2 to the y is the same as these parentheses are equal to a 2 to the y equals x. Alright, I've got 10 to the power to another power. We multiply these exponents together. 10 to the log base 10 of 2 multiplied by y. These two things are multiplied together up in the exponent equals x. This is an exponential. Let's rewrite it as a logarithm. As a logarithm, it's going to be a log base 10 because the base under our exponent is now a 10. So this will be a log. I'm going to put the 10 there for emphasis. Log base 10 of x equals what the exponent is. The log base 10 of 2 times y. Well, remember our goal was to find out what y is equal to. So let's just divide both sides by this coefficient. Divide both sides by the log base 10 of 2. And what we find out is that y equals the log base 10 of x divided by the log base 10 of 2. So let's put this in a nutshell. What we found out was the log base 2 of x is equal to the log base 10 of x if we make this division. So change this how? Here's how we change this. It's equal to the log base 10 of x divided by the log base 10 of 2. Now, there was absolutely nothing magic about the number 10 here. If we had wanted this to be a log base e, a natural log, then here when we changed the base of the exponent, it would have been e to the natural log of 2. And what we would have ended up with was the natural log of x divided by the natural log of 2. Any logarithm can be changed into any other logarithm by just dividing by the base of the original logarithm. Here's what I mean. Let me say this in one more slide. If we've got the log base something, base b, of some number, m, and we feel like changing that into a log with a different base, I'm going to call the new base c, then it's the log base c of m, the number we wanted to take the logarithm of, divided by the log base c of the original base, which was b. To see this in action, let's bust out our calculator here. Say I want to do the log base 3 of 27. This is an easy one because we can do this one in our head. We know the answer is 3. But let's see how we can get it off our calculator when our calculator doesn't have a log base 3 button. Here's what our calculator will tell us to do. Our calculator's going to say, I should take the log base 10 of 27. Remember, we're trying to do the log base 3 of 27. I'm going to take the log base 10 of 27, and I'm going to divide it by the log base 10 of 3. So if I did the log, the log log, so that's the log base 10, of 27, we get that number. And if we do the log common log, log base 10 of 3, we get that number. If we were to divide those numbers, the log of 27 divided by the log of 3, we get exactly 3 because the log of base 3 of 27 is 3. And that's what this does for us. Now, it doesn't matter if we use the log log or the ln log. If we had done the natural log of 27 divided by the natural log of 3, we still get 3. It doesn't matter what base we change our logarithm into. So we can do any base we want just by making it a division problem, which means we really don't need both of these keys on our calculator. We don't need both of these buttons. We really only need one logarithm button. But the people at Texas Instruments have been nice enough to give us both buttons because 10 is a pretty common one. That's why it's called the common logarithm. And E is another very common one in the natural logarithm. However, the TI-84s, just TI-84s and TI-Inspires, not the TI-83s, have a shortcut that allows us to get past this division. All the calculator is doing is this division, but they're making it so we don't have to type it in. If you've got a TI-84 and you hit alpha and the window button, choice number 5 says log base. And so if I go down and I choose number 5, it puts in log with a little space for the base there. Log base 3 of 27. And it spits out the answer 3. All it's doing behind the scenes that it's not showing us is doing this division. You can verify that for yourself by seeing what error it gives you when you take the log of 1, the log base, I'm sorry, not the log of 1, the log base 1 of something. I'm not going to do that in the video. I want you to do that yourself. Use this function on your calculator. Again, that was alpha and window to choose choice number 5. Use that choice on your calculator to do a log base 1 of something and see what the error message is. It's going to give you an error, but what error message is it? And we want to discuss why that is the error message that you receive.